So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of GCSE exam style questions on real life graphs at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description below, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started working through this test, it's worth noting that there is no indication about whether these questions are specifically for a calculator or a non-calculator paper. Now, this topic can appear on both papers, so it's worth just bearing that in mind when you're working through questions. So what we'll do when we're working through these questions, we'll try and avoid using a calculator where possible. So let's have a look at question 1. So question 1 says, here is a conversion graph between two units of pressure. So we've got PSI and we've got bars. Now a tyre needs to be at a pressure of 30 PSI. What is this in bars? So what we need to do for this particular question is to look at PSI and we're looking for 30. So that's going to be at this point here. And what we need to do is just project horizontally until we hit that line and then just go down. And that works out to be anywhere between 2 and 2.1 bars is going to be the equivalent of 30 psi. The next question then says that a racing bicycle has a recommended pressure of 7.5 bars. What is this in psi? Now looking at the graph, it only goes up as far as 3.5. So what we need to try and do is manipulate to try and get 7.5, but using the horizontal scale that we've got. Now there's a couple of ways in which we could do this. We could work out what 1 bar is, and then which is going to be roughly at around 16, I would say. So it's around 16 psi. So then if I then multiply that by 7, so if I multiply both sides by 7, or 7.5 rather, then that is going to give me a value of, and let's just get the calculator out to work that out, of 7.5 multiplied by 16, which gives me an answer of 120. So then we can write down 120 for that one. So then looking at the next one that we could use, so I could use, let's say, 2.5 bars. So 2.5 is here, and I would say that's roughly going to be about 36, I would say. So then if I multiply both of those numbers by 3, then I'm going to end up with 7.5 bar, which is what I'm wanting, and 36 multiplied by 3, which if I do on my calculator, I get an answer of 108. Should be an I there. And or what I could do is I could go for 3.5 bar, which is here, and I work that out to be around about 52, 51. So let's just go for 51 psi. So if I multiply that by 2, then I get 7.5 bar and 102 psi. So any of those answers, as long as you've used the graph to manipulate any of the numbers that we've got available on the horizontal axis to try and get 7.5 is going to be absolutely fine. And with the question being worth 2 marks, it's definitely worth noting what is rather than just writing down one number. It's worth noting what you've used to try and get 7.5 and what number you've multiplied both of those sides by. Looking at question 2, it says water is poured into a container at a constant rate until it reaches the dashed line. One of these graphs show the change of the depth in D of water against time t. Circle the correct letter. So as you can see, this graph starts to slow, it starts fast I should say, then it slows down and then it increases again. So what we're looking for is a graph that replicates that, and that is going to be graph A. B then says that, let me just go with that cursor, it says the graph shows the change of depth D of water D against time t as the container is filled at a constant rate. Which of these is the container? So as you can see that we start with a steady rate and then all of a sudden it slows down. So which of these has 2 stages in which where it starts slow at a steady rate and then all of a sudden it just goes a bit slower, and that's going to be option B. Moving on to question 4, it says that this graph shows the relationship between the width, the W, and the length L of a rectangle with a fixed area. Write down the width when the length is 5. So what we need to do is find the width, which is the vertical axis. We need to find 5, and then all we need to do is just go across and then head down, and I get that to be 7.5. The next question then says work out the fixed area of the rectangle. So for this, all we need to do is just multiply the width by the length, which is 5 times 7.5, and where I've got that from is these two measurements here, and I get an answer of 37.5. Then for C, it says when the length and the width are equal, the rectangle is a square. Use the graph or otherwise to work out the length of the side of the square. Show clearly how you've obtained your answer. So if you're going with otherwise, well, we know that the area of the rectangle is 37.5. So if it's a square, all the sides are going to be the same. So if I then do the square root of 37.5, let me just do that on my calculator, and I get an answer of 6.123. So we're looking at roughly around 6.1. Now again, if I go back to my graph, I'm looking for the values of where it's the same along the X and the Y axis, or L and the W axis, and 6 is probably going to be around here, and you can see there that on the graph that this value here and here would be the same at around about 6. So I would say an answer of around 6.0 to 6.2 should be okay. Moving on to question 5, it says that Tom cycles to his grandmother's house, which is 12 kilometers from his house. He stays there for 45 minutes. The distance time graph shows his journey, and the question is asking to work out the fastest speed that Tom cycles at on his way to his grandmother's house. Now for this, what you're looking for is the steepest part of the graph, which in this case is this length here. Now to work out the average speed, or the speed, I just need to do the distance divided by time. So here the distance is 8 and the time is going to be 30 minutes. So let's just have a look at what the units they want. So they want kilometers per hour. So I've got 8 kilometers, and I just need to make sure that my time is in hours. So it's going to be half an hour, which is 0.5 hours. And that works out to be 16 kilometers per hour. The next question then says, write down Tom's average speed on his way to his grandmother's house. So for this, we want the total distance, which is 12 kilometers, and the total time, which is 1 hour. So it's 12 kilometers divided by 1 hour. So it's going to be 12 divided by 1, which is 12. Next question then says that Tom cycles home at an average speed of 10 kilometers per hour. Does he get home before 12 noon? Clearly show how you get your answer. So if he's traveling at 10 kilometers per hour, let me just write that down. So 10 kilometers per hour. So if he leaves at 10:45, then by the time it gets to 11:45, which is here, he's going to have traveled 10 kilometers. Now 12 take away 2 is 10. So then all I need to do then is join those two lengths up there. So let me just do that accurately and best that I can on here. Just fix that line there. So this represents 10 kilometers in 1 hour. And then if he's traveling at the same speed, then that's going to continue. So if I just project that line downwards, you can see that if this is 12 noon, that he is going to arrive before that time. So the answer then would be yes, he gets there at, and then it's just a case of just guessing the time. So 11:45 is going to be here, and so I would probably say it's around about 11:55, or in other words, after 11:45 but before 12. Moving on to question 6, it says that this graph shows the first class postal rates. How much does it cost to post a first class letter that has a mass of 300 grams? So looking at 300 grams, it's definitely between 250 and 500. So we're looking at this bracket here, and that is £1.68. Looking at question B, it says this graph is called a step graph. Explain why it's called a step graph is used to show the postal rates. Now again, the reason for that is you could give either of these possible answers, that there is a fixed price for each range of weights, or you could say all masses. So any of those would be absolutely fine for you to save that one single mark. For question 7, it says here is a graph and it's a distance travelled meters over time, and it says what is represented by the gradient. And for this one, it should know that it's speed, as the gradient is going to be the distance divided by time, which is speed. The next question, it says write down in words the units represented by the gradient. Well, it's going to be the distance units over the time, so it's going to be meters per minute. And then moving on to our last page and last set of questions, it says that a tiler uses the graph of C equals 0.25t plus 20 to work out the charge of C pounds for a job that involves fixing T tiles. What is the gradient of the graph? Now the gradient of the graph is going to be 0.25. It then says what does the gradient of the line represent? Well, it's going to represent the cost of fitting each tile. And then what does the constant term represent? Well, that's going to be the fixed cost, or you could say it's going to be what we call the call out charge, so the price they charge you for knocking on your door. And that concludes the end of this test.